Today I'll be showing you how I built my 3D printed circular sock machine. Hi everyone, welcome back to my channel Hella Knits. My name is Julia. Today's going to be a bit of a different video. It's kind of an instructional video. I mentioned in my last few videos that I was going to build a 3D printed circular sock machine, and so I did. The machine that I built is called the CSM for My Mom and You version 2 with a ribber, and it's by JeepingJohnny on Printables, which is a website where you can share 3D printing files and projects. So all of the files required to build this circular sock machine are available for free on Printables, and I'll link it down below. I hope you can see that. Oh boy. This is my 3D printed circular sock machine attached to a table, as you can see. And I had all of the parts 3D printed from a local business to me in PETG plastic. The hooks and the cylinder spring are from Angora Valley Fibers. Some of the hardware and the digital counter are from Amazon. I also ordered all of the nuts and bolts from Canada Bolts, and any wires and metal rods that I used, I just got them from my local hardware store. The table I got from Canadian Tire. Somehow I managed to find the flimsiest table out there, so I would not recommend the one that I got, although it was only $20, so it's pretty cheap. This is a Laguerre style machine, so the collar rotates around the cylinder that the needles are in, as opposed to an auto knitter, which has a rotating cylinder and a stationary collar. This video is just going to show you how I made the machine itself. There is also a ribber attachment, which I did print the pieces for, and I have all the hardware ready. I just haven't put it together just yet. When I do, I'll record that and put a separate video up. So this machine is right now just able to make a stockinette tube and no ribbing. There's also a document attached to the project that has some tips and tricks from the creator of things that worked well when they were putting it together. There's also a lot of information in the comments and make section on the Printables page from other people who have made it, with their advice and questions that have been answered by the creator, which was really helpful in me building my own. But I really found that there was a deficit in terms of instructional videos of step-by-step how to put this thing together. So as I was building it, it was a bit of trial and error, and I definitely did have to build it and take it apart a few times. At the end of the day, I managed to get it working. I have made one sock so far on this machine successfully. The second sock is still pending. As I was putting it together, I did record all of the things that I did and tried my best to explain what I did as I was doing it. I wanted to compile all of those clips together and share them with you in case you're interested in building one of these and maybe a bit confused by the instructions on the Printables website. That's what this video is today. It's essentially just a compilation of clips of me building this machine. I apologize in advance if it's a little chaotic. The audio and video is a little inconsistent throughout all of the clips. I wasn't really thinking too hard about my setup as I was building it. I was more so focused on trying to get it right and trying to explain as best I could how I put it together. I'm definitely no expert. This is just what I did based on the instructions on the Printable page. But if you have any questions at all, just let me know in the comments, or you can comment on the Printables page itself. There's a lot of people there that have also made this machine and are more than willing to answer any questions and possibly have had the same questions as you already answered. That's enough chatter, so I guess we can just get right into it. Today I'm going to go through how I'm putting together my circular sock machine. So the first step, you're going to take your crank arm, which is this piece right here, and you're going to need a flange shaft coupling, which looks like this. And then you're going to need some 16mm M4 size bolts and 4 M4 size nuts. And so what you're going to do is take a hammer and hammer one nut into each of these hexagonal spots on the curved part. So now that I've done that, I'm going to line up the 4 holes here on the crank arm with the 4 holes on the bottom of the flange shaft coupling and screw them into place into the nuts. Make sure as you're doing this, you're actually holding the nut on the back because you want it to catch. So now you can see they're all screwed into the bottom, and we have our 4 screws all the way around. So now what you're gonna do is take the crank gear, which is this piece right here, and we're gonna pretty much do the exact same thing. So you need 4 of the M4 nuts, these ones. And this time you're gonna actually need the M4 12mm, so slightly shorter. What I'm first gonna do is just hammer the nuts into these little hexagonal openings. So I'll be right back. Okay, so now I've gone ahead and hammered the nuts into the back. I honestly don't know if you need to, but it makes it a lot easier when you're going to screw the bolts into the other side. So you're basically gonna do the exact same thing. Find the 4 holes on the front of the crank gear, and note that this is the curved side, not the flat side. So on the curved side, get another flange shaft coupling here, and then just screw the bolts in through into the holes. All right, so now I have the flange shaft coupling screwed into the crank gear. For the next part, basically you're gonna need some wheel bearings here. So what these are is basically two metal rings, and they rotate independently from one another. So you're gonna need that. You're gonna need your crank arm with the flange shaft coupling on it. You're gonna need the crank wheel with the flange shaft coupling on it. Now we're gonna need the frame, which is this piece right here. And you're also gonna need a piece of metal. So this is an 8mm diameter metal rod. I believe this is steel or stainless steel. I got this at the hardware store, and you can get them in different lengths. The shortest that I could get was 3-foot length. So what you're gonna have to do is actually cut it to length. So this is a 65mm or 6.5 centimeters. What I did is I used a hacksaw, and I basically measured and just cut the length that I needed, and then I took a metal file and I filed off the edges just so they weren't super sharp, so it was a little safer. And then what I did is I took some sandpaper actually, and I sanded around to make it just ever so slightly skinnier. You're gonna wanna do this because basically when you slide this through all the parts, it's very tight. So that's everything that you're gonna need. The first thing you're gonna wanna do is put this wheel bearing into this hole here on the frame. Now you're probably gonna have to hammer it into place because it is quite tight. It doesn't just slide right in there. So I'm gonna do that and I'll be right back. I've hammered the wheel bearing into place on the frame here right in this hole. So now what I'm gonna do is kind of create a sandwich. So you're gonna take the curved side of your crank arm that has the nuts on it and place it on a surface where you're able to hammer underneath it. Then you're gonna line up this center hole with the center hole of your wheel bearing, just like this. Finally, you're going to take your crank arm and line up that center hole. Basically, this crank arm is gonna slide right into this rectangular slot on the frame. So you slide it into place just like that, and all 3 of the holes should line up down the center. Then what you're gonna do is take that 8mm piece of metal and essentially hammer it through all of these pieces. You're gonna basically want it to go through all the way through. So I'm gonna do that and I'll be right back. Okay, so I'm just jumping in here quickly as I'm hammering this. I've hammered it part of the way through. As you can see, the wheel bearing is starting to come out the other side. So what I've done is this looks a little bit sketchy, but I've taped the crank arm in place so that as I'm hammering, the pressure is going straight through the rod, through this hole, and it's not pushing the wheel bearing out of place. Okay, so I've finished hammering. So I'm hoping that you can see now that I have the rod hammered essentially flush with the end of this flange shaft coupling and also the end of the one in the middle there. So the rod has gone through, it's gone this entire length, okay? So it's pretty much centered. I think you can get away with having the rod just be a little bit longer. As long as it's centered between the 2, that's fine. And once you're done, the crank gear should sit nicely in this groove and it should be able to rotate freely, just like this. Okay, so the next step is going to be putting your crank handle on. So this is the crank handle piece. It has a thick end and a skinny end with a hole down the middle. You're going to need an M6 size bolt that is 65 millimeters long at least. I think you can use 68 as well, as long as it's long enough to get from one end of the handle to the other. That's really what matters. And I think as well, you don't want to go too long because the bolt is going to go through the handle right here. And so you don't want it to be so long that it exceeds the gap, this little gap here. So you're gonna need the bolt. You're also going to need an M6 washer and an M6 size hex nut. Slide the bolt into the thick end of the handle, just like so. This end of the bolt is gonna go through this hole on the crank arm, and you're gonna secure it with a washer and a nut on the other side. So screw the nut in so it's finger tight first, just so it doesn't fall off. Okay. So just take a pair of pliers to hold the nut in place and then use an Allen key to tighten. And now we have a crank, and it cranks just like that. One more thing I almost forgot. So the flange shaft couplings, they have the 4 holes here, right, on the flat side, but then if you turn them, you can actually see that they have a hole here. Let's see if I can get that to focus. A hole here on the neck, and they actually come with these little black screw-shaped pieces that fit into these holes so you can tighten them onto the bar. They come with a tiny little Allen key. I have a little black piece in here already. So I'm gonna just go ahead and tighten that. This is going to secure that 8mm rod into place. Okay, so that's nice and tight, and then you're gonna repeat that on the inside here. Okay. All right, so now that 8mm rod is tightened on the neck of the flange shaft coupling. So now it's really secure. The next thing to do is to take a 1/4 inch diameter steel rod and cut it to length. Now this is going to be for the mast of your yarn stand, and there's not actually a designated length in the instructions of how long to cut this to, but I basically just held it up, saw how it looked, and decided to cut it to 20 inches. Now I could definitely cut it shorter. I think there was someone online that said they cut theirs to 18 inches, but 20 is what I decided. And basically what you're gonna do is take the yarn stand base, which is this piece here, line the 3 holes up on your frame and this, and tap the rod all the way through the center hole, through the base, and through the yarn stand. So I'm gonna do that now. To me, there's honestly really no good way of doing this. Basically what I did is I took this rod and I put it rod side down on the ground, and I hammered the bottom of this first. So I basically did it upside down, and I was hammering this way. And then once I got all the way through the yarn stand base, I placed the frame on top and lined it up, and I hammered the top of this here. I'm not entirely all the way through. I don't know if you can see that, but to me, this is really firm in there and it's not going anywhere. So the instructions call for 12mm bolts to go through these holes, but actually it looks like to me that they're too short. Essentially, I played around with it and there was literally no chance that I was catching this nut in a 16mm bolt. So I wound up just using the 20mm, and that works fine. Here I am just putting the second bolt on the base here. And these are the M3 20mm length, not 12, because there just was no world in which I was gonna fit 12. Okay, great. So that is secure there. And then I believe I need to use a 20mm to go across here. So let's see if that is going to fit. Yay, okay, perfect. So I'm going to just secure that as well with a nut. So what I would probably do is just take a pair of pliers. Okay, perfect. So that is secured in there like that. The next thing that I'm going to do is take the yarn stand sensor bracket, which is this piece here, and the yarn stand weight, and I'm going to tap them onto this 1/4 inch pole at different heights. Okay, so the next thing I'm going to do is take the yarn counter bracket and put that on the 1/4 inch rod as well. As you can see here, I basically took this piece and I slid it all the way down the 1/4 inch pole down to about the level of where the cylinder is going to be. I line up the slots on the same side, and then all I'm going to do is take a 12mm M3 bolt and secure it with a nut right through that hole. So what I did when I was putting this down the top of the rod, I actually just hammered it just to get it on, and then I was able to slide it down by hand, as you can tell. But that's how I got it down there. So now this is secure. This is the yarn counter sensor bracket. So I just wanted to jump in here. Excuse the different lighting and audio. This is much later, and I realized that the instructions that I'd given you guys for assembling this yarn stand sensor were a little confusing, so I wanted to clarify them. You take the yarn stand sensor bracket and you attach the yarn stand sensor pivot, which is this piece here, this curved piece here, and you basically attach them with an M3 size 20mm length bolt and an M3 size nut just on this side. Then what I did is I used the screws that came with the yarn counter. So this is the yarn counter display here. I took this metal piece off the back. It's normally attached with 2 little screws. So I took the screws off to remove the metal piece, and then I just slid the screws back through each hole in the flat side of the pivot. That's essentially what I did. Then what you're gonna do is you're gonna want to assemble the rest of the pieces on the yarn stand. So if I zoom out a little bit, you can see the entire yarn stand here. So this is the sensor bracket, this is the yarn stand base. Moving up, we have the digital counter bracket. Then you slide your yarn stand weight on it, which actually has no real resistance. I think this is for creating a heel. And then the next few steps are going to be putting all the pieces onto the top part of the yarn stand, which is called the yarn stand guide, I believe. So if you can see the top here. Okay, so I will go through how to put those pieces together next. Back again here in a different location. In the last clip that you saw, I had installed the yarn stand. Currently, this is the state of what we're dealing with here. So let's see if I can show it to you better. Currently, I have the yarn stand base, the holder for the counter sensor, and the magnet, which I just have separately right now in storage. And then I have the counter bracket mounted and the counter display here, which I've set up. So you can see it turns on there, and then as the magnet passes, the counter counts up. So that's what I have, and the yarn stand now needs a top piece. So I'm going to put together the top piece, which is called the yarn stand guide, but I think that I'm gonna wait to install it on the top of the yarn stand until I put the center cylinder components in. But I'll put this together first. This is something that the yarn feeds through, and the top of this hole is actually gonna sit in the top of the yarn stand at the very tip of that rod. You have the yarn stand brake piece here. So this piece is called the yarn stand brake. This piece is called the yarn stand guide, and I was able to get the full version. I think there's 2 versions, so if you happen to have a smaller 3D printer, there's a smaller version that you can put together in multiple parts, but the person that I commissioned this print from had a large enough 3D printer for that. And then this is the yarn stand pivot piece here. What you're also going to need for this step is to cut some 1/8 inch diameter metal rods. This is how the pieces fit together here. The yarn stand brake sits just like this. As you can see, there's multiple holes along the side here. These holes line up with these holes, and your 1/8 inch metal rod is just gonna go straight through here. Another piece, the pivot, goes in to this slot right here. And as you can see, there's another 1/8 inch size hole that goes all the way through. After lining these up, I just used a ruler and measured. You need a metal rod that's this length and a metal rod that's this length to go through all of these pieces. The 1/8 inch rod that I cut for this length was 5 centimeters, and this one is 1 inch or 2.5 centimeters. They're pretty much the right length. I think this one's slightly a little bit long, but I don't know if it matters if it's too long. I think what would be more difficult is if it were too short, then you wouldn't be able to push the rod all the way through. Now that that's all done, gently tap each of these rods through their respective holes and fasten all 3 of these pieces together. I put the 5 centimeter 1/8 inch diameter rod through this set of holes, and I put the yarn stand pivot here. Make sure you put the curved side up. It moves freely within this spot here. And then I have the yarn stand break. In hindsight, I maybe could have made a slightly longer rod. This one is a little bit too long. This one might be a little too short, but for now it works and this isn't falling off. What I did realize is it's helpful to start hammering, and then after that, just take a pair of pliers and grab the metal and kind of twist it and push it through the hole, and then tap it with a hammer at the end. That's what I would recommend for all of the metal rods, to be honest. What I also found I had to do was line up the holes and tape them before I started hammering or pushing the metal rod through, just to make sure the holes are lined up. This hole in the center slides onto the metal rod at the top of the yarn stand like this. And before you do that, you have to put the yarn stand weight on the yarn stand. This is the yarn stand weight piece. What you're gonna do to assemble the yarn stand is take the yarn stand weight and slide it on to the yarn stand, and then you're going to attach this on top. And I'm pretty sure that's all of the components on your yarn stand. After that, you're gonna take some metal wire. You hook the wire onto here, up through the hole on the yarn stand pivot. I'm not going to do that right just yet because I want to assemble the cylinder, which is essentially the knitting part that goes in this hole. I think it's going to be easier to do that before I put all the yarn stand components together. So that's what I'm going to do next. What I'm going to do to assemble the cylinder and collar section is to put together the yarn carrier pieces. This is the yarn carrier base. This is the yarn carrier stem, and this is the yarn carrier guide. I believe what you're supposed to do is attach all 3 of these things first, and you also can attach the magnet into this hole on the yarn carrier stem. What this is going to look like is this curved part on the base is going to face the inner circle where all the knitting is happening. This yarn carrier stem is going to go on with the little dash lines. They're going to line up with this hole just like that. So they attach like this, right? And then this is the yarn carrier guide, which is going to attach this slot onto this hole. So altogether you have 3 pieces, and you're going to attach them with M3 size bolts and nuts. I pushed the magnet into the hole here. This flat side of the yarn carrier stem is going to face the counter sensor, so I think I'd rather have it closer to that side just to make sure that the sensor picks it up. So there you go, the magnet is in there. So you can see it's nice and flush. Now I'm going to screw these together. So it says to use an M3 bolt to attach the base to the stem. Because there's a notch here instead of just a hole, I'm not really sure how high it should be, but on the pictures it looks like it's just kind of in the middle. I'm just gonna try that and see how it goes. I mean, I guess it can, the whole point is that it can be adjusted. So I'm just sliding it just right into the middle. So we've got that screwed in, and now we're gonna screw the yarn carrier guide, and I guess I'll just do this one in the middle as well. Get a 12 millimeter M3 bolt and an M3 nut. So make sure it's oriented the right way so the curved sides go together like this. So I'm going to put the nut in the bottom first, hold that in place, slide the bolt through, make sure it's oriented the right way. There. So I just used this Allen key to push the nut into that hole there. So this is the yarn carrier components. Okay, so last I saw you, I assembled the yarn carrier guide, stem, and base. The next thing to do is attach this component onto the collar gear. Identify the flat side of the collar gear, not the beveled side. Find the 2 holes on it. I went ahead and I just pushed some M3 size nuts just into these holes on the base of the yarn carrier. The curved side goes inwards toward the center of the circle. Line up these holes, these 2 holes with these 2 holes. I use an M3 16mm bolt. Just put it through each of these holes here. Line it up and use an Allen key to screw it in. Good. Okay, so these are nice and snug. And so now we have the yarn carrier component attached to the collar gear. The next step is going to be putting your cylinder into the collar. This is the 64 stitch cylinder with this little bump in it is called the ribber stop. So I did print the parts for the ribber attachment as well, but I haven't put that together yet. From what I understand, you can use the cylinders with the ribber stop, whether or not you have a ribber. I think it works either way. So I'm gonna start with a 64 stitch because that's the size for my foot. You can see these holes on the bottom, and those are gonna correspond to the 4 holes on the cylinder, and you're gonna have to put a bolt through the bottom of them and screw it into a nut that's in these little divots. So before we put the cylinder in, I'm actually going to just pop in some M3 size nuts in advance. So I already practiced this actually yesterday just to make sure I had the hang of it. These are hexagonal. So you want to slide it in so that the flat sides are going this way. So take the flat sides, identify your hole, and basically just slide it in. So now the nut is in there. I guess you could use a pair of forceps for this as well. Anything that kind of pinches it in there, because I found that I was having difficulty just pushing it in with my finger. I think there are some little filaments of plastic. That happens, just rip them off. Right, so it looks pretty good. I have a nut in each of these little slots. These are the needle lift cams A and B, and they're these kind of funky shaped things here. I'm not a 3D print expert by any means, but from what I understand, these are kind of a difficult geometry to print nice and smoothly. You typically have to sand them. That's what I went ahead and did. I think it's this curved part. This curved part, it definitely wasn't not this smooth when I got it. You basically have to take some sandpaper and just sand it down until it's smooth. I don't know if it's smooth enough, but I was worried that I would go too far, so I just sanded it a little. And the same on this side. I think it was mostly this side, so I'm not too worried about that. But I did sand them down so they're a little bit smooth. We'll see how these go. I might have to change these later on, but we're just gonna work with these for now because this is what I have. You're gonna take the collar piece, which is this funky looking guy right here, and then you're gonna grab the needle lift cam. So you're gonna find the flat side on the little wing shaped piece and slide it vertically into the slot on the collar. So you slide it down and rotate it into place, and it should be flush with that little rim on the inside of the collar. And do the same on the other side, so they're kind of flush. And the reason you want them to be this flush is so that they can easily slip under the needles and lift them up as you're sort of cranking around. So now we have that nice stack that I showed you. We're gonna take the cylinder and line up the nuts with each of those 4 holes. So it should go something like that. Now you're gonna take 25mm M3 bolts, and what you're gonna do is pop them underneath the frame here and screw them up into those nuts that you put. Excuse my very messy desk area, but I wanted to just show you what this looks like. So we essentially have the cylinder that I screwed in here. You can see the 4 screws. Let me show you what it turns like. We have the sensor for the counter here connected to the digital counter display here. This is the yarn stand weight, which I believe a wire is going to go through on the next step. And then I have the yarn stand guide with the pivot and the brake that we attached earlier. I slid it onto the top of the 1/4 inch rod here, and I put a 20mm length M3 size bolt through with a nut on the other side to secure it. So it looks pretty good. These are the needles. I think these are size 7. You take the needles, find where the little foot is, and all the feet are gonna stick out away from the center of the cylinder. And all you do is just slide them and drop them right in each slot. They should fall in nice and easily. And then I have a cylinder spring here. You basically just stretch it and slide it into this notch here. So this is what the sock machine looks like with all of the needles in each of the slots and the cylinder spring in that notch just around them. The needles should move freely inside of each of their slots, so if there's any resistance, you may have to sand down the inside of the slots. For my print, I didn't have any of those issues, but just be aware of that. I've seen some people had issues. And I actually did take out one of the needle lift cams. My other one needed some sanding, so I took it out for now. This is the collar tension cam, which looks like this. And I put an M5 size nut in this hole. And then you take the collar tension cam bolt holder, which is this little wedge shaped piece, and put an 8mm M5 size bolt inside of it. And what you're gonna do is just take it point side down and slide it into this slot here just behind the notch in the collar piece. Then you're going to take the collar tension cam bolt holder, line the back of that bolt up with the nut on the inside of the collar tension cam, and just screw that in to place. So the last clip that you saw was just the machine not mounted onto anything, so I wanted to kind of finish the instructions here just to explain how I put the wire in the heel spring and also how I attached my machine to my table. I guess I can explain what a heel spring is. Okay, I really hope that you can see this. This part is called the yarn stand weight. This part up here is called the yarn stand pivot. From what I understand, the function of a heel spring allows you to crank the machine back and forth in 2 directions, so you can knit short rows essentially to create a heel on your machine instead of cutting in after the fact and doing an afterthought heel. I have yet to use this function yet because one of my needle lift cams is kind of rough and needs some sanding in order for me to put it in and it to work smoothly working the other way. So I only have one of them in right now. My machine only cranks in one direction, but I wanted to explain to you how I went about finishing the heel spring. The heel spring requires 20 gauge wire, so this is just a coil of steel wire I got at the hardware store. I wasn't too sure the length of wire that I needed, but I just kind of guessed based on the pictures that I was seeing. So this piece here is a piece of metal wire. Let's see if I can show you that. So there's the metal wire. I think this was about 8 inches long. And what I did is I just cut with some wire cutters an 8-inch piece of metal. I slipped it through the endmost hole on the yarn stand pivot and bent it 90 degrees. And then I slipped the other end through this hole on the yarn stand weight and bent the last inch or so up to kind of hook it into place. So now these two are connected like that. If you want to use the heel spring, you'll need a second piece of wire that's about 6 to 8 inches long again, and you're going to put it through the other end of the yarn stand pivot. I will put a picture here of what other people have done because clearly I don't have that in my machine, and I believe your yarn kind of hooks around that, if I'm not mistaken, to make a heel. In terms of actually mounting the machine onto this table or any table for that matter, I highly recommend printing this piece. I think it's just called the template, and it's pretty skinny, but it basically outlines all of the holes that you'll have to cut in whatever surface you're mounting it to in order for it to fit. So this hole in the center, I believe, is 3.75 inches, and these holes on the edge are about 5/16 of an inch in diameter. When you're lining this up on the edge of your surface, you want to make sure the edge of your table doesn't go beyond or cover up this rectangle here, because this is where your gear is going to go and it has to rotate freely. So obviously if there's the edge of your table in the way, it's not going to rotate. The other thing to note is it's actually quite difficult to find a 3 3/4 inch hole saw cutter or like a circular drill end to cut this large central hole. If you're gonna deviate from the size of this template, I would go bigger rather than smaller. If your hole is too small, it's going to most likely catch on your knitting as you're cranking your tube. So it's better to have the hole slightly bigger than slightly smaller if you don't have the exact size for this. And then when you're mounting the sock machine on your table, you put your bolts in the top of the holes, and then you have some 3D printed washers and nuts that just screw underneath the table. So you want to make sure that the surface of your table doesn't exceed the length of the frame bolts that come in the 3D printed project. What I did to cut these holes is I recruited some help. One of my boyfriend's friends was able to use his tools to help me cut these holes in this table. So although I actually got to have a turn drilling one of the holes, I did not do this myself. I definitely owe him a pair of socks once I figured out how to use my ribber. I think that is all I have to say about my circular sock machine. I hope this video is helpful and you're able to follow it relatively well. Like I said, if you have any questions at all, just leave them in the comments below, or you can check out the Printables page, which will be linked down below as well, so you can have access to all the files and all the information that I had when building this. I want to thank the creator of this project, JeepingJohnny, so much for sharing this project for free. I can't believe that I was actually able to build this and get it working. Thank you so much for watching. I hope this was helpful, and I will see you in my next video. Bye.